Let's start. My name is Suszynski, and I will be talking in English. This presentation is about the event mesh and why you should use probably event mesh and not service mesh in your application, especially if your application is designed in a microservice way, a distributed way. So a couple of words about me. I'm a senior dev at Red Hat. I work on OpenShift serverless, and I mostly work with Go, with Rust, but sometimes also in Java, but I have also a quite extensive background in Java. There are a couple other technologies I currently work on. So I'm an open source contributor. I have multiple open source original repositories, things that I built. And also I'm a father. I have a great son that I'm happy about. So let's see what we will be talking about today. So first of all, let's talk about transactional, and why transactional is often a lie in our application. Also, I will be saying about the eventual consistency and how eventual consistency is actually better approximation of real world in our applications, and also why the serverless service mesh is often seen as a solution to a lot of problems when dealing with microservices, but it's actually often a wrong solution, not suitable for us. Yeah, and actually we will be talking about CQRS, what it is and how we can use it. And I will show you the eventual consistency in practice in terms of actual Kubernetes, how Kubernetes is done in the engine of Kubernetes, essentially. And of course, about the event mesh, that's the title. So we will be talking about that and how Knative implements this pattern. And of course, demos and code and everything that's great, right? So about transactional, I think I said that this is a lie, and probably everybody is here familiar with transactionals and transactional processing, but real transactional is actually rare. I was working in all sorts of companies out there, also banks, and I never have received any request from anyone in business that I should do a real transaction, meaning the at least two things need to happen, or none of those things need to happen, right? That's the transactional. And we do all transactional all the time, transactionals, in our apps, but we never receive any intent to actually do that. So that's bad, right? So we overuse this massively. I will show you code in a second. And this overuse actually distorts the idea, the business logic that is supposed to happen. And of course, it's slow and also error prone. So that's also a problem. And here is a code example. This code is actually from a legacy fighter application. You might know that application. This is actually the end state of the refactoring. So that's a pretty good course that advice probably you could take if you work in legacy code. But this is the end state. So I took this example, this method from this application to showcase you something. Take a look at this code. This is a complete transit method. So this code is about some Uber-like business, right? And we have complete transit method, right? And this whole method is annotated there with transactional, right? So let's highlight things inside of this method. All of those highlighted in red are actually operations that are changing the state, right? All of those. So we have 1, 2, 3, 4, 5, 6, 7 different operations that actually change the state. and we have transactional there. So if this method throws exception at any point, any method actually, not only in those, but in any method, all of this will be rolled back, right? All of this will be rolled back, and we will actually lose data, right? What we are losing? We are losing this intent of completing the transit, because our user already clicked this button, he already do the thing that he's supposed to do, an application thrown an error on him, right? But he already did that, right? So probably he will hit the button once again or whatever. We get used to errors, that's another topic, right? But what we should supposed to actually persist is this thing, this intent of the user. I mean, the intent of the user to complete this transit is the essence of our business logic here. This is the one thing that's supposed to happen, and only this thing. All other operations could happen later. It's not a problem looking at the business level, right? So, yeah. And who writes code like that? I was writing code like that. I've seen code like that in multiple places. I especially take code from this application because it's supposed to be good already, right? It's after the refactoring. This is the end state, right? And still, we have things like this. So we get used to writing code like that, right? In our day jobs. Yeah. So let's imagine what we could do about that. Yeah. So instead of using transactional processing here, let's imagine what we can do with eventual consistency. So we will try to do the same operation, but in eventual consistent way, right? So let's imagine, for example, we do the obvious naive split of those modules. I also took this example because the code is already modularized into different packages, so it's actually quite easy to imagine you just take some module and you just put it as a separate service somewhere, right? So I marked in different colors different modules that we have in here. So we have address, we have transit service, we have driver fee, driver service, and we have award service and invoice service. So a couple of services that are used here, right? So let's imagine we just magically tap this code and we have that split it as a separate services, right? What happened then? Well, now we have 12 remote calls to 5 different microservices. So if we have a really good infrastructure, maybe even we are using service mesh like Istio, then we probably could reach 99.99% of uptime for each of those services, right? But this still means that the end uptime is actually far, far lower. So we are still in unacceptable realm of operation, right? So we are still below anything. And really, you shouldn't be losing any data. So any number below 100 is actually unacceptable, right? How you would say that to your business? Oh, we are just losing 0.2% of the data. That's not a big problem, right? Yeah, and of course, this approach is at least 1,000 times slower, or maybe even 1,000,000 times slower, because those are now separate. And also, there is this possible loss of data. We have also a possibility of losing data previously in transactional operation, right? But yeah, so here it's even worse because we just split those. So yeah, service mesh. Service mesh often is seen as a solution to writing microservices, right? So often people said if you write microservices, you should probably use service mesh to retry your operations and so on and so on. But I just showed you that using service mesh is not enough. It will not fix this problem. There will still be the data loss in your system, and this is not acceptable to design it in that way. So actually, what is possible is to actually use the service mesh only for things that are safe to retry. So things like queries, right? So queries are synchronous, remote calls, and we could use service mesh for those. But, yeah, let's talk about the CQRS. What it stands for? It stands for command and query separation, basically. And we have two things, command and we have that are asynchronous, so they operate asynchronously. They are AKA events, basically. And we need to make sure that we don't lose commands, right? So there are commands, and we have queries, right? And queries are synchronous. Queries have this request-response model. And also, queries are safe to retry. So that last thing, I mean, they should be safe to retry. And that last thing actually tells you that the service mesh could be applied here, but it doesn't give much for us, right? It doesn't really improve situation because the queries are already safe to retry, right? Yeah, so let's take a look at our example. We have commands, right? In our example, the main event will be actually complete transit. This is the main event that is actually happening. And this event will fan out to a couple of other events, like update destination, because somebody actually changed the destination during the trip and maybe is driving to a different place, right? And also things like we should calculate fee for the driver, right? Driver is actually free to take another transit after he completed this transit, right? We are registering miles in some award program as well. And also we need to issue an invoice, right, as well. So those are those events that are delegated from the main event. And we have queries like read transit, read address, and a couple of others as well. So let's now see an example of how Kubernetes is actually written and how Kubernetes might be an example of eventual consistent system. So I don't know if you are aware of this, but Kubernetes is made this big mostly because it's extensionable in that way, and we could actually create extension like this. We are defining some type. This is actually Go code. We are defining a type called memcached, right? And this type has two fields. It has spec and we have status. So spec is actually set by us, and status is set by Kubernetes operator, right? And in this example, we might have something like size that might, I don't know, mean number of nodes that we would like to have of memcache. And in the status, we have nodes that actually, number of nodes that are ready, maybe, right? It's up to us to define both of those and what they actually mean. And this is how it's done in the background, I mean, in practice. In Kubernetes, you have those controllers. The other name for that is operators. And they implement method called reconcile. And actually, you are receiving here a request, and this request parameter is pointing you to the type that actually has changed. So we are operating here on the memcached type. There is written there, and we are getting the value from the database and checking what we should do with it, right? So we are essentially reconciling the state of the system to match the expectation of the user. Yeah, and let me show you a real example of that. Here I have a piece of code, not this one. Yeah, this one. This is an operator that I wrote, and this is actually called passless operator. And we have type like this defined here. So we have object of type passless, right? It has a name, and we have this specification here. And what we have in this specification, we have a couple of things, right? We have length, we have a scope that is set to alphanumeric, and we have version number 1. And the idea of this is actually to write things like this in your repository, to commit code like this in your repository instead of committing secrets somewhere, right? So you are writing this to your repository, and then you have also a controller that handles those. So we have this method called reconcile, right? And we are receiving here this request, and the request, if we go to this object, is actually things that is namespaced, and we have name and namespace, 2 fields. So we have exact pinpoint of the resource that actually is changing currently. And what the reconcile is doing. Essentially what we are doing, we are reading this passless type from the database. This is the client is reading here. We are getting the errors. If everything is fine, that means we have our object here written in this value, right? And if we have that, we can generate a secret, and that will actually create a Kubernetes secret object using some algorithm in here. That's actually a generator that is using those values to generate the password. And after that, I'm just writing that secret down to the Kubernetes. So here, I'm creating this secret, right? Or if the secret actually needs updating, so that means the secret's been already there on the Kubernetes, the secrets get updated, right? And if everything is fine, that means we are exiting from this function and the state is reconciled. If any error occurred, like you can see here, we have errors, right? And if any error occurred, we just are returning this error, and Kubernetes will automatically recall our method here. So you are probably aware of this pattern that you deploy something on Kubernetes, and he tries to deploy your image, deploy and fail, and he constantly tries to reapply your change until it essentially succeeds or leads some limit, right? So that is how the Kubernetes is actually done in the background, and it is example of eventual consistent system that actually will retry operation until the operation is successful, right? But watch out for this implementation. You could also write your code, business code like that, but this feature actually relies on this database called HTTD, right? This base of almost every Kubernetes out there, and it has a watch feature. So the database actually could watch for changes in elements stored in database, and whenever it actually changed, you could receive your operation there. So that's how this actually is being done under the hood. And that works until a point about 100,000 records. So that's why Kubernetes has limits like that, like 100,000 nodes, 100,000 pods, or 100,000 namespaces, and so on and so on. This is basically all boils down to HTTD as an implementation. Yeah, and let's see the other example. I mean, the solution that I'm proposing here. So this is actually called event mesh, and how we could use event mesh to develop our application in the consistent way. So what is an event mesh? Event mesh is a pattern, so that's a thing that you could write differently, right? So that's a thing that is sitting somewhere, and it is a configurable, dynamic thing that will distribute your events and also decouple your applications from each other. So essentially, applications don't know from where they are receiving events and to where they are sending the events. And that allows us to enable communication to be governed, flexible, reliable, and also fast, right? So this table, I think, quite well capture the similarities and differences between service mesh and event mesh. Service mesh meaning something like Istio, right? So similarities, we have flexibility. Both of those allows us to do flexible code. Robustness, so we have things like repeating operations, right, whenever they fail, and decoupling, so our application don't know about each other. But there are key differences. The event mesh is synchronous. We have operations like request and response. So this means naturally it's better for queries, right? It's naturally better for those operations. And event mesh is primarily designed to be asynchronous. So that's only one-way operation. So this is just sending somewhere something, and event mesh respond to you, okay, I got it. I got your event, so that means the event is safely stored on the mesh, right? And of course, it's for events, right? That means this is better for commands, because commands are events. This is basically the same thing. Command, event, intent, this is the same thing. Yeah, and OpenShift Serverless is based on Knative, and this is a product that I'm working on currently in my day job. And the Knative is an extension to Kubernetes, similar to what I showed you before, like this passless operator. We have Knative operator there that actually adds a couple of CRDs, custom resources, and this allows you to deploy serverless apps, but also there is this component called eventing that actually give you the event mesh. And we will be talking about this other component, the event mesh, today. So Knative in OpenShift is, of course, a CNCF Foundation open source project. It is a community-driven project by multiple stakeholders are contributing. So it was started by Google, but nowadays Red Hat is the major contributor. The most guys there are from our company. We have other companies like IBM, VMware, Trigger Mesh, and SAP as well, and other contributors. So here are some resources, and this is the latest production-ready release. We have production-ready release for about 2 years already, so already we are used by a bunch of customers in production. Yeah, and let me show you the demo that I wanted to show you today. So first of all, this is the application that I was showing you before. And I took this application specifically because it's already written, refactored to be modular, right? And I just took one of those modules and I extracted the module, exactly the driver module. I extracted the driver module and I rewrote the driver module logic to Rust. So now I have a separate Rust service for drivers. But I didn't want it to change the code totally, so you still be familiar with the same code. But take a look. First of all, we don't have a transactional right now, right? So that's the first change that we have. We still have complete transit, but no, it's no longer transactional method. Here we have a self field that might be a bit strange to some of us. And actually, yeah, I'm injecting myself to myself. What the hell, right? What I'm doing such thing? Yeah, maybe after we could show, if somebody knows why I'm doing that, I have a cup for you already. So yeah. Okay, we have first person that knows. Let's focus about the other stuff first. So we have this, most of all the same code, but now things like calculate fee is extracted. So before this method was actually returning the calculated fee already, and the money was then persisted in the same method, right? But now, let me go to that method there. So, like, it's now just publishing some event, right? So we have calculate fee event here, and we are publishing that. Let us go there to this code and see what happens here. So we have an event of some kind, and we are converting that to cloud event. Why is that? Well, this is the base of Knative implementation of event mesh. We are using the cloud events library, so that's a separate thing. And cloud events is basically a specification, and also you have a library for different languages. And here I'm using this because I have a Rust implementation and Java implementation. And in both places, I could just use a library, and that's it. But even if you are using some like strange language, whatever, you could still create a HTTP method and just call it, because cloud event is basically just a specification, just a Rust call, basically. And what I'm getting here is I'm getting the sink address, and the sink is basically a field. Here's this field, and this field is configurable by Spring configuration, right? So here I'm getting the k_sink variable, right? So you could define this variable here in environment outside of my application. You are probably aware about Spring configuration. In Quarkus, this is called cloud configuration or something like that. Yeah, so I'm getting the address here, and I'm just sending HTTP call with this cloud event somewhere, right, to this address. And that's it. I'm exiting here, and if I have received some not successful code, that means something failed. The event wasn't being delivered, right? But if the event was delivered, that means what? That means I'm exiting from all of those methods here with void, right? So I'm going to the next method there, the final method, and the whole processing is ending here. Yeah, so let's see what happens on the other side. So this method is actually going into the mesh, right? The mesh will then send the event to the other application, the Rust one. Let me show you this. Yeah, this is the Rust application. And here we have some files, like this file is actually for implementing the route of the cloud for cloud event. I have other files here as well, like for example, the main file here is, I think, this one, and this just implements bunch of REST resources for this application, right? So we have bunch of things like getting drivers, creating drivers, and such, activating them, whatever. This is just a business logic of this application. But also we have this events here file, and what we have here, we have a path that is handling post messages that are coming to the main endpoint, and whenever they come, we are invoking this function, and this function will expect the cloud event to be there, right? So this will actually automatically, this code will automatically create the cloud event for us, and what we are doing here, whenever we have the type of this event like this, we are invoking the calculate fee method, right? Excuse me. Yeah, we are invoking this method, and this method will actually do some work, like we are calculating fee, we are receiving money here, and if we receive this money, I mean, if this succeeded, we are just creating another event. That's just a class here. I'm creating a type with driver ID and the fee that is calculated, and I'm sending that event, right? So here I have a sender, and the sender here is sending this event. And this is similar code that I was showing you for Java. So here I'm just creating some HTTP client. I'm just sending this event into this client as a post message somewhere. And also I'm sending to the same variable called ksync that is being handled here, right? So we have here a Knative sync configuration, configurable variable as well, right? Now this is a different language, but you should be, well, familiar with that. This looks similar to Java, right? So what I'm actually doing is I'm sending this event, and if the message is successful, everything fine, and if not, I'm just throwing an error, right? And that will propagate forward until the route, and the route will return 500, right? So that means the message doesn't work. And on the Java side, because then we'll be going back to the Java, right? Yeah, let's go to the Java. So on the Java side, we need to capture that somehow, right? So I have a receiver class, and here I have a post mapping, similar to what I have in Rust. Right? Do you agree? Like I have a cloud event here as a parameter, so that should come from body. And whenever I receive that cloud event, I just look up my my converters. Whenever any converter like this matches, I will just call the converter, like I have here a matching by type, right? And I will just create a specific business event that I need in my application. This is actually my Java version of the driver fee event, right? So I'm creating that event, and when I got that, I just publish that event onto the internal Spring publisher, yeah? And you probably know that you could write something like this, event listener. So this might be a little bit confusing because we have external events and we have internal events here as well. That's just a Spring machinery. In Rust code, I didn't have that, so I just have a simple switch, and I was calling method from there, right? But here I have some Spring magic, and I have this method, and whatever driver fee is calculated, this method will be called. And if that actual driver fee is received, what I'm doing here is I'm actually persisting, updating the transit with this fee, right? And this is actually transactional, right? So this needs to be transactional because I'm updating the database, right? And that's it. We just extracted the method. We made the system a bit faster because now we are not waiting up for the fee calculation that is happening in background, and we all still have the same logic. So let's actually call that code. I have also here this already deployed on Kubernetes. This is actually Kubernetes cluster, and this is a OpenShift flavor of Kubernetes, basically the OpenShift distribution of Kubernetes. And we have two services deployed there. We have a legacy application that is this Java application written in Spring Boot, and we have a drivers that is actually written in Rust. And all of those are deployed as a Knative services, and that's why this driver service auto-scaled to 0. I purposely set a minimum scale value for the legacy application to not scale it down, because I need to basically show you the operation. And that's why I created their development data. Let me show you maybe this quickly as well. So we have here the dev data, and this is just some Spring component that is running in development profile only. We have a bunch of auto wires here, and whatever application is starting, basically I'm just writing some development data into my in-memory database, right? You're probably doing something similar in your apps. on development side, right? And I just done this to make it easy for myself because as you can see, creating a transit is quite, well, extensive, right? So I'm just creating that transit and I'm writing here on the console, in order to complete this transit, just call this with those parameters, right? Yeah, and that's why this application, I need this application to be started, because it's actually having the data in memory, right? And the other application is just using this Redis database for its data. Yeah, so this is the code, and let's deploy our mesh. But first, maybe let me show you the files quickly. And this is not this one. I forgot to open the project, yeah. Yeah, so we have here the database, the Redis database, the drivers, and the legacy services here defined. But we have also the mesh, right? And the mesh, the main part of the mesh is actually the broker. So the broker has a name. It has also namespace as well. But we have the delivery here. That means actually whenever there is an error in delivery of the events, please retry 10 times, up to 10 times, and use the exponential backup. That means it will try sending the event after 0.2 seconds. If that fails, it will send the event after 0.4 seconds. If that fails, it will send the event after 1 second. And yeah, I mean, you get the picture that we are increasing the period, and this actually summarized to about 5 minutes as a whole. So essentially what we are doing here is saying, please retry up to 5 minutes, right, in exponential way. This is the broker. We have also two sources, and the sources are called sync binding. What this actually means, it means that whenever there is subject like this, that is this service called drivers, put any events from this service into the broker, into the main broker. And the same here for legacy. So whenever either one or second one sends those events, send that to the broker. And we have triggers, two triggers. So if there is an event called type with this type, calculate fee, please send that to the drivers module. And if there is a event with this type called driver fee, calculated driver fee, please send this to legacy application. Yeah, so let's deploy this on the cluster. So we have deploy and mesh. So we will deploy this on the cluster quickly. So all of those get created, the broker, sync bindings, and two triggers. And we could also see that on the here on the web page. So this is the broker part, right? And here we have two sources, and those lines are representing the triggers. So actually, if I type one of those, I could see like this is filtering only this type of event, right? So this UI is actually pretty nice, because you could see that events will be coming from here and to here, right? Of course, there should be also a link from here to those sync bindings, but, well, it's missing for now. Yeah, and what you could see is that the value here changed. I mean, we have version number 2. Why is that? We created those sync bindings, and this actually changed those application automatically for us. And if we go to the YAML of those apps, we will see like they have a injected parameter called casing, right? And this parameter is actually pointing out to our broker. So we don't configure that, we just apply the mesh, and mesh automatically configured that for us, right? So that's why actually the application also was redeployed. Yeah, and let's go. As you can see, the drivers module is getting terminated, so this is a serverless feature. But let's see the logs of the legacy, and here at the end we are receiving this my message to complete the transit with some data. But in order to see that better, let's show you this like that, and then maybe I will also open a second window. Yeah, we got something. No. Oh, we got the code. Yeah, so we have this message. So we have some active transit already, and we would like to call our code, right? Let's do that right now. So I have a function prepared here already, but let me first boil it down what it actually means. So this part is actually our CLI, and yeah, one problem, I need to use proper kubeconfig. So this is our CLI, and what it actually does is just getting the address of my service, right? So I know how the address of my legacy application here. So I'm just calling HTTP on these drivers for the transit number 8 to complete, and I'm giving the value like country, city, street, building, and some hash that the code expects, right? So let's tap this and let's see what will be happening here. So we are expecting that the legacy application will do some work, will send the event to the mesh, mesh will send the event to the drivers module, drivers will calculate something and create additional event that will be sent it to the mesh, and in the mesh we should send the event back to our legacy application to complete the loop, right? So let's try doing that. Yeah, we already see some operations that already completed, and we are getting the driver fee calculated. But let's read what actually happens. So we are getting some Spring information here, but now we are seeing like we are publishing event to the broker, so we have address of the broker, and here we have a cloud event, and this event is actually of type calculate fee, right? And some data is attached to the event. So this event went into the mesh sent this to the other module, the Rust code, and here we are receiving events, so this is another endpoint, so this is another thread, another operation, right? So here we have receiving some cloud event, but other type. This is actually driver fee, calculated driver fee, right? And the code is called, and that's why we are here seeing this final value, right? So the operation went into two ways. Yeah, and what is important here is that whenever something fails in our code here, like for example, if we have a bug in processing of event, the transaction, this operation will return error, and broker will automatically retry sending us our event, right? Yeah. So this actually is how the mesh is working, and the key takeaways from this: please don't force transactions, right? I mean, that should be the obvious thing. Transactionals, like in the beginning, are often the anti-pattern that we are forcing on our companies. We shouldn't be doing that. Please persist your events. So if you are using events, persist them and make sure they are persisted. Sending them to the event is actually a good way of doing that, because we are make sure that if event mesh return for us 200, that means the event is safely stored. And using event mesh could allow you to decouple applications. Like I showed, the apps doesn't know anything about them. They don't know anything about the mesh as well. And what I show you here is different, and I think is far easier than using event sourcing. Of course, you could use event sourcing, but event sourcing is far harder than this approach. This approach is using actually the short event queue. So event queue, short event queue for the win. I mean, this is far easier for everybody to understand. So we have regular database and short event queue that they get consumed, and we have state. Here are a couple of resources about this, and that's it. Thank you for this. First of all, let me ask, why is the self needed there?
I think Spring usually, it depends on the configuration, but usually doesn't know how to execute the transactional. It's an aspect. When you are calling it with this, so you are calling it on the same object. Yeah. Spring doesn't know how to instrument the code.
Yeah, that's right. So you take a cup, but it's even a bigger problem because it's not a Spring problem, this is Java problem. Java have annotations, and annotations are just labels, and they are not doing anything on their own. They need annotation processor or proxy object to actually do any work, right?
Yes, but if you use, for example, aspect J, it would execute with this.
No, I mean, there are still aspects, and this is just done by aspects. Yeah. Okay, so any other questions? I mean, actual questions about the event mesh or Knative or whatever?
So, in your opinion, what's the key in using this service mesh via Kubernetes than Kafka or other IMQP solution?
Event mesh, you mean event mesh, not the service. I mean, the main difference is the coupling, because if you're using Kafka directly for sending events, reading events, you are couple yourself with Kafka, right? So in order to develop or test or whatever, you need Kafka, right? And that's the main difference. Here, I just could set up WireMock server and just test regular HTTP, and I know that I'm doing the good thing, right? Okay, so it's far easier to use just event mesh like this. Any other question? So if not, thank you once again.